Hello students, welcome back to my channel. Today we are going to study about chains, branches and rings. Carbon atoms forms compounds with different type of arrangement such as long chain, branch chain and cyclic chain structures. Long chains means they are also known as linear chains or straight chains. Then branch chains are there, then cycling rings are there. Let's see from an example. For example, if you take butane, that is C4H10. Let's see how we can write butane. There are 4 carbon atoms. It is satisfied by 10 hydrogen atoms. The valencies are satisfied by hydrogen atoms. Let's write the condensed formula of this butane. That is CH3, single bond, CH2, again single bond CH2, again CH3. Now as you see, this is a straight chain. Butane can also form branch chain. Let's see how. Instead of 4 carbon atoms, we write 3 carbon atoms there. 1, 2, 3 and 1 carbon atom we will write it as a chain. Okay, in the second carbon atom we are writing as a chain. Now let's satisfy all the valencies. Carbon atom is satisfied by hydrogen atom there. This carbon atom have 1, 2, 3, 4. And this carbon atom is also satisfied with hydrogen. This carbon, the branched one is also having hydrogen there. Now we'll write the condensed formula of this one. CH3, single bond, CH, the branched one that is CH3, again CH3. This is the branched chain of butane. As you see, the same molecular formula, that is C4H10, but different structures. This we call it as structural isomers, which have same molecular formula but different structures. Butane has 2 structural isomers. First one is straight chain, the other one is branched. Now let's see another example, that is pentane. We know pent means 5 carbon atoms. So and it is ane, that means it is alkane. So C5H12. How we can represent pentane? 5 carbon atoms satisfied by 12 hydrogen atoms. After writing, you have to check whether it is correct. 5 carbon atoms there surrounded by 12 hydrogen atoms. Now what is the condensed formula of pentane? That is CH3, single bond, CH2, single bond CH2, again single bond CH2 and CH3. Now let's see how many structural isomers are possible for pentane. So this is the straight chain of pentane. Let's see the branch chain of pentane. So here instead of 5 carbon atoms I am taking 4. So that I can take one as branched chain. satisfy all the valencies over there. 1, 2, 3, 4. 1, 2, 3 and 4. So it will satisfy all the hydrogen atoms. This branch chain also have hydrogen atoms. Now we will write the condensed formula of this one. CH3, single bond CH, single bond CH3, CH2, CH3. So here the branched one is CH3, methyl group. So this is the branched chain. Let's see another way of writing this pentane, another branch chain. We'll take 3 carbon atoms and 2 carbon atoms like this, branched one. So there also valencies are there. So we have to satisfy with hydrogen atoms. Let's write the condensed formula. CH3 single bond C. There up there is CH3, down also CH3, the branched one. Then comes CH3 there. So this is the branch chain of pentane. First one is pentane, the other one is isopentane, and the third one is neopentane. So there are 3 structural isomers for pentane. First one straight chain, another one branch chain, and also next one is also branch chain. Now comes the next topic, that is ring compounds, or we call it as cyclic compounds. Ring compounds means they are closed chain compounds. That is, the 2 ends of a chain of carbon atoms are joined together. So there are saturated ring compounds and unsaturated ring compounds. Let's see what is saturated ring compounds. As the name suggests, saturated means it will be single bonds, carbon-carbon single bonds. So let's see one example, that is cyclohexane. Formula is C6H12. So let's see how we can represent that. In a ring form it should be, that is closed chain. So 1, 2, 3, 4, 5 and 6. So it forms a ring. The 2 ends of a chain of carbon atoms are joined together. So first of all, they are joined by single bonds. Each carbon atom needs 2 hydrogen atoms to be satisfied. So here this carbon have 1, 2, 3, 4. This carbon have 1, 2, 3 and 4. This also 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Here also 1, 2, 3 and 4. All these we can satisfy with hydrogen atoms. It is correct. Cyclohexane, that is C6, and hydrogen atoms are 12 hydrogen atoms there. Here it is a saturated ring compounds because they contain only single bonds. Now how will you write the condensed formula of this one? This can come under CH2, again CH2 here, then CH2, again CH2. The valencies are satisfied, thus it forms a ring compound. See the unsaturated ring compounds. Unsaturated means it contains double bonds or triple bonds. So here we take double bonds. Example of unsaturated ring compound is benzene. Formula for benzene is C6H6. Here benzene is made up of 6 carbon atoms, in which each carbon atom is joined by a single bond on one side and double bond on other side. Let's see how. First you have to write 6 carbon atoms. Let's join them by single bonds. Benzene, each carbon atom is joined by a single bond on one side and double bond on the other side. That means there is alternate single and double bonds, and that is satisfied by, the others are satisfied by hydrogen atoms. Let's see, this carbon atom have 1, 2, 3 and 4. This carbon atom 1, 2, 3, 4. This carbon atom have 1, 2, 3 and 4. 1, 2, 3 and 4. 1, 2, 3 and 4. So each carbon atom needs one more hydrogen atom. That's all. It is balanced, C is 6, then H is also 6. So there are alternate double and single bonds. See how we can write the condensed formula of benzene. Single bond CH. First you will write all the single bonds. Satisfied by alternate single and double bonds. So since there are alternate and double and single bonds, it can also be drawn as like this. These are the chains, branches and rings. So let's see in the next video. Thanks for watching.